Hey guys, in this video I want to walk you through calculating the interval estimate, which is also the same thing as the confidence interval estimation. So let's do that using this particular example. And here we have a sample of size 10 of federal income tax returns from last year. And let us say the IRS has established that the standard deviation of errors made on the returns is 12,000. So right there we know that sigma, which is the population standard deviation, is given. So it is known. So this is one of the things you want to look for in these problems. Is sigma known or not? If sigma is known, we can use a normal distribution, which is a z. If it's not known, then we have to use the t distribution. In terms of the questions we want to answer, the first one is, what is the point estimate? So the point estimate for the mean is x bar, because x bar estimates mu, while mu is the population mean, which we don't know. That's the whole reason for doing this process. So we need to find x bar in this case. Then for b, we need to do the margin of error. That's based on the 95% confidence. In part C, we have to do the confidence interval based on the 95% confidence level. So let's get right into it. Here we see the sample of size 10 over here. And on the right hand side, we see the formula for the interval. And let me show you what that is. So this is x bar, which is the point estimate, plus or minus, this whole thing forms what we call the margin of error. So we need to break these components down to make sure we understand each one. Let's go ahead and go to the Excel formulas. So on this sheet, we need to first find the sample size. And the sample size, the way we do that in Excel is just to count the number of observations. So we're going to say count, and then we select all the cells. In terms of sample mean, that's going to be the average. So we need the average of all the numbers. We again do that in Excel to get that number. And then the population standard deviation is given. So we did not need to calculate this thing. It's given in the problem. So we just use that number. In terms of level of significance, we know that's 5% because the confidence level is 95%, right? And remember, confidence level is 1 minus alpha, and alpha is the level of significance. If our confidence level was 90%, then for level of significance, we'd have to use 10%. Let's get to the margin of error now. And there are two ways to do this. The first way is to look at the various components and use Excel to find them. So for the first one might be the trickiest a little bit, to find z alpha over 2. So make sure you understand how to find z alpha over 2. You can sketch the bell curve and then you shade the areas in the lower and upper tails. And those areas should be equal to alpha over 2. So that means if our level of significance is 5%, we need alpha over 2 or 2.5% in the lower tail and 2.5% in the upper tail. So that's what this formula represents. So we are going to say norm.s.inv, and here the norm.s means standard normal, and the inv means inverse. Inverse means we're looking at the area and we need to find the z value, as opposed to norm.s.dis when we have the z value and we want to find the area under the curve. So we're looking in reverse, hence the name inverse. Okay, so we have that part covered. Once we have this figured out, we need to multiply by the number in D6, which for us was the population standard deviation, sigma, divided by the square root of the number in D4, which was the sample size. And so we have that. There's a little tricky bit. Whenever you do this procedure, the norm.s, and you use the lower tail, you're going to have a negative number. So the way to get around that is just to put a negative in front of the formula. So put a minus norm.s to get rid of the negative that's going to result. And here we end up with the positive margin of error. So that's our goal. The other approach to finding margin of error is to use the built-in Excel command for margin of error. And it has a weird name. It's actually called confidence.norm. So it's not called margin like I would want it to. It's called confidence.norm. So you have to know that gives you the margin of error. So let's see the components of this thing. And for this, I like to go up to the function. Let me see if I can show you that. So once you select the formula, you can go up to the function up here and click on FX. And once you click on FX, you're going to see this dialog box open up, and it's going to tell you what you need to input. And I like to use it because it tells you exactly what you need to put in. Here it says put alpha. So it says alpha, not alpha over 2. So you need to put the alpha value of 5%, 0.05. And then standard deviation is your sigma, which is 12,000. And then the sample size is 10 from before. So you could click and just click the different cells, and it will do that for you as well. All right, so now we have the margin of error. The last step is to go ahead and add and subtract the margin of error from the point estimate. So for the lower limit, we need to say it's the x bar plus, minus the margin of error. So negative 7,000 minus negative 7,000 would give us negative 591,000. And our upper limit is going to be the same point estimate plus the margin of error, so that we have this. And we'll state this as the 95% confidence interval is negative 14,591 to positive 283. So there we have it.